This video talks about compound or compounding interest, and that occurs when interest is calculated or compounded on both the principal amount and the accrued interest thus far. In other words, for each interest period, the interest is calculated and then dumped into the account so that the next time interest is calculated on a larger amount, and it's doing that then repeatedly. Um, from the previous video, if you want to think of interest as being compounded only once a year, we would have used something like that, where A is the amount in the account currently, P is the principal or what you put in, R is the rate, and T is the time. But if interest is compounded at different intervals, meaning if interest is compounded monthly or quarterly or daily, we need to adjust that formula a bit. So A equals P times 1 plus R over N raised to the NT power. Again, P is the principal, or the starting amount, the initial amount, what you're investing into account or what an account starts out at. R is the rate, typically in years. N is the number of compoundings in a year typically. For example, if interest is compounded monthly, N would be 12 since there are 12 months in a year. If interest is compounded quarterly, then N would be 4 because interest is being compounded 4 times a year. T then is, again, time, typically in years. So the first example, Laura deposited $12,000 into an account that earns 8% interest. How much money will she have in 5 years if the interest is compounded quarterly? So A is the amount in the account. That's what we're trying to determine. P, the principal, or what you put in, your starting amount, in this example is $12,000. 1 plus R is my rate, 8%, but just as in the other examples, that's as a decimal, 0.08, over quarterly is how frequently the interest is being compounded. So that is N, and that is 4. Now that same value that's in the denominator, dividing up or splitting up that rate, is also in the numerator. Okay, again, this N that is here is the same N that is here. So that 4 will be there, but now that 4 is also multiplying the time. In this case, time is 5 years. So 4 times 5 is the power. So then when you go to your calculator, you're just being careful to enter everything in correctly, 12,000, and then in parentheses, 1 plus 0.08 divided by or over 4. Now your calculator knows its order of operations, so you don't need to put an additional set of parentheses there because it'll automatically divide before it adds. Now your exponent is going to be 4 times 5, which is 20. I usually go ahead and make that calculation in my head if I can, because sometimes I am careless to not enter that exponent correctly. And again, to 2 decimal places, that gives me $17,831.37. So as long as you know where to put those values, these problems really are not bad. Number 6 says Jack took out a 6-year loan for $25,000 to purchase a boat at a 4.5% interest rate. If the interest is compounded monthly, what will he have paid total over the course of the loan? So A is the total amount that he will have paid. The initial cost of the boat was $25,000. 1 plus R as a decimal, so 0.045 over N. Again, N is the number of compoundings, how many times interest is being calculated a year. And this time it's monthly, so that's going to be 12 months in the year. That same 12 that's in the denominator is also in the exponent as the power. And since he wanted the loan for 6 years, that's 12 times 6. So again, as I go to my calculator, 25,000 times 1 plus 0.045 over 12, close my parentheses, to the 12 times 6, that's 72. So that's the 72nd power. And when I hit enter, overall, even though the initial price of the boat is $25,000, with interest included, he'll wind up paying $32,732.58. So again, each of these problems pretty much is handled in the same manner. It's just making sure you know where the numbers go. Number 7, an investment pays 3.9% interest, compounded semi-annually. Okay, semi-annually means twice a year. If $4,000 is invested in this account, what will the balance be after 12 years? So again, I've gone ahead and started to plug in values. 4,000 is my original amount. My interest is 0.039. Again, that's as a decimal over, and I've got an additional a decimal point down there that I don't need, over, since it's semi-annually, that's twice a year, and that same 2 will be in the power, and you're wanting to know the balance after 12 years, so the exponent will be 2 times 12, or 24. So again, 4,000, then in parentheses, 1 plus 0.039 over 2 for semi-annually, or twice a year, raised to the 24th power. So after 12 years, that investment will be worth $6,358.48. Then number 8 and number 9 are just a little bit different just because of the final value that you're asked for. So number 8 says a savings account offers 0.0 or 0.8% interest compounded bi-monthly. That means twice each month. If Bob deposited $300 into this account, how much interest will he earn after 10 years? Since the interest rate is 0.8%, that will be 0.008 over, now twice a month. If interest is being compounded twice a month, that means twice a month for 12 months, that's going to be 24 times in a year. That same 24 will be in my power, and if you're wanting to know 10 years, that 24 will be times 10. Okay, so again, twice a month for 12 months will be an overall 24 times that the interest is compounded. So 300 and then 1 plus 0.008 over 24 raised to the 24 times 10, that's 240th power. I didn't get my 240 into my power, so let me key that in kind of quickly again. Okay, So unfortunately, that balance is not nearly what it would have been previously. So that saving Bob will only have earned total in the account $324.98. Now, the other reason why this problem is a little bit different besides the twice monthly piece, this problem asks just how much interest will he earn. It doesn't ask how much will be in the account, but how much interest will he earn. Well, if he started off with just $300 and now he has $324, that means he will have earned $24.98 in interest. So just make sure before you walk away from a problem that you have answered what is being asked. Don't miss the problem just because you didn't answer what was being asked. And then the last example, suppose you invest $750 into an account that pays 3% interest compounded weekly. So that would be 0.03 compounded weekly. There are approximately 52 weeks in a year. So the number of compoundings will be 52. That same 52 will be in the power, and after 20 years, well, that 20 will be up there in the power as well. Then as you start keying things into your calculator, 750 times 1 plus 0.03 over 52 raised to the, now this is an example where you might not know off the top of your head what 52 times 20 is. You can put the n times the t in your power and your calculator can handle that just fine. A piece of advice is for those folks that have or are using an older calculator, an 83 or an older 84. When you key this into your calculator, you need to make sure that once you hit the caret key, you put 52 times 20 in parentheses and close your parentheses so that 52 times 20 is considered to be the whole exponent. Otherwise, you won't get the correct value of $1,366.35. So I encourage you, if you haven't taken the time to this point to enter any of these into your calculator, stop now and make sure that you can get this number 9 entered into your calculator correctly. But again, to answer the question asks how much interest will you have earned after 20 years. It doesn't ask how much is in the account, but how much interest will you have earned. So that means you're going to subtract off the original investment, and I can do that over here in my calculator. So that last value minus what I put in originally, and that gives me an interest amount of $616.35. So just be careful as you're entering in these numbers into your calculator and make sure that you are actually answering the question that is being asked. And now you should be able to do the back side of your homework assignment that begins with number 6, talking about compound interest.